Okay, now we are recording. Okay, so I told y'all we were going to start this week in chapter 6, and we are starting. And I'm just going to go over a lot. Like I told you, I'm going to go over hit and miss with probably 6.1 and 6.2 because I went over a little bit with you, and I told you that you needed to make sure you wrote those index cards down and all that good stuff. But I need to go over 6.1 and 6.2 first because that kind of leads into the logarithms. And I realize that one or two of y'all have sent homework questions on like 6.5 and 6.6. I don't want to get the cart before the horse, so just if y'all could just wait, and I will get to those questions when we get there, okay? So, with that being said, inverse operations. That's what the first thing we're going to talk about is, inverse functions. And I'm not going to go into a lot of what inverse functions are. I'm just going to show you because I think sometimes these slides can be a little bit going around the world. So I'm going to click on this, and I'm just going to show you what an inverse function is. Let's say I give you a function like f of x is equal to 8x. And I want you to find the inverse of 8x. Well, the first thing you do is you rewrite with y. So I'm going to rewrite this. Y is equal to 8x. The second thing you do, switch x and y. So that means I'm going to put y right here, and I'm going to put x right here. And the third thing you're going to do is solve for y negative 1, because that's basically what you're going to get. So divide by 8, y inverse is equal to, and you could say 1/8x or 8x over 8. I'm going to say 1/8x. Okay? Now, what is this? Well, it's the inverse of, this is your original function, and this is your inverse function. So let's graph the inverse function so you can see what it is. So y is equal to 8x. And since 8x, we're going to make 8x equal to black, since it's kind of the base function. So I'm going to change it to black. And I'm going to change y sub 2. I'm going to make that equal to blue. Y'all are impressed, aren't you? I figured y'all would be. Okay, so my first one is y is equal to 8x. And the second function is y is equal to parentheses 1 divided by 8x. And hit graph. And
Hey,
you notice, I'm sorry, what?
I'm letting you know that it's saying that the recording stopped. On my end, at least.
I don't understand. I've still got it going and the red light's still on. I don't know what's up, but is anybody else, do you see the recording button right there? Everybody see that? And it's moving.
I see the recording button, but in the chat on my side it said recording has stopped. We're saving to Microsoft Stream and it'll be available shortly. So it's like, I don't know what that means.
It still says recording in the top left, though.
Okay, I'm gonna keep it going. It says it's going. I understand what you're talking about. I don't know. I don't know what to do because if I start it over, then I got 2 videos. So I don't know what, let's see, 9:20. I don't know what the heck it's doing. It says it's recording, so I'm gonna leave it since my recording is the only one that matters because I send it to stream. I meant to YouTube. I'm gonna leave it running because mine says it's running, and we'll just see what happens. Okay, I'm sorry if I mess up. I'm sorry. No, you're not interrupting. Thank you, Miss Bronson. Let me move this back over. I'm going to see when I go to it, it says it's recording. So I'm going to leave it alone. I'm not going to mess with it. Let's see what happens. And I just read y'all's, my audio and video are lagging. What about the rest of y'all? Is my audio and video lagging?
Yes, sir.
Yeah, it's lagging for me too.
Oh, well, I don't know what to do. I've already cut off my video. So I don't know what's going on. Maybe it's just a bad day. I don't know. Okay, so anyway, you see that this black function is going left to right, and this function is going. Now, what happens with an inverse function? Well, I'm going to show you. Yeah, exactly. It's post-election. Yeah, it's the Russians. Don't even get me started, Miss Bronson. I'm so irritated right now. I don't know what to say. I don't know what to say. So trace. Now I'm gonna show you something here. Hit the trace button, and let's just go to 1. Just find 1. Okay, look at that 1 right there. Let's mark that, and that's 1. I'm gonna draw a picture here. And that point is 1.06, comma, 8.48. Okay, and that's the number close to 1. X is equal to 1.06. Now I'm going to turn it around and I'm going to hit enter. Oh, well, let me go hit trace again. Trace. Well, it should go to the next. Why won't it go to the other? How did I get it to go to the blue lines? Anybody remember? Is it second enter?
It should be one of your arrows that switches lines.
There we go. I got it. Down. All right, now watch what happens when I go to, let's see, trace. .48. Somebody notice anything?
It's the opposite of the other points.
8.48 and 1.06. Write that down because that's what you need to know for an inverse function. Okay? The inverse function basically is the flip-flop with the x and y of each other. Now you're going to really see it here in just a second. I'm going to give you another example, and you're going to see it. Okay, so what you need to know here, this is a test question. I'm going to show you the test questions. 2 test questions here. One, there's one test question. Right here. Make sure you can take a function and turn it into the inverse function, or find the inverse function. That's the first test question. The second test question is to find the relationship between a function and its inverse. And the relationship is this is x, y, and this is flip-flop, technically y/x. Okay, but I don't want to say y/x because it's not. In other words, these switch on an inverse function. Okay. All right, let's do another one. And this one you'll see a little bit better. Here is the basic function. And I want you to turn that into, I want you to find the inverse function. Follow these steps. Follow those steps right there. And I want you to find the inverse function of x squared. Do that right quick. Give you a few seconds to do it. You should have this written down. I'm not going to leave that on there because it's kind of busy with both of them on there. So the first thing I'm going to do is I'm going to rewrite it. The second thing I'm going to do is I'm going to switch the x and the y. Third thing I'm going to do is I'm going to solve for y and call it y inverse. And that right there is my inverse function. So if I was to graph this, y is equal to x squared and then I change this one to pink, since I've got a pink. Where's my pink? Magenta will have to do. Things I do for y'all. And that's equal to y, or I'm sorry, x to the what? To the 0.5 power. I hate when it does that. X to the 0.5 power and graph. Now, as you can see, you only got half a graph. Why do you have half a graph? Because you can't take the square root of negative. But I'm going to draw it because I want you to see the actual, so our basic function looks like a parabola going upward. And the magenta now, let me show it to you. Now, the reason I dotted that is because you can't take the square root of a negative number. So that's why this does not exist. But as you can tell, if you were to find the inverse function of the black function, it would be on its side, and this is called a hyperbola. And I'm just going to write that down. A hyperbola is a parabola on its side. Okay, so test question right here. Test question right here. Now, of course, if you wanted to find out where it intersects, you would set these two equal to each other. Square root of x is equal to x squared, and have fun with that. Or you could just use trace and intersect and find the intersection point. Now, one other thing that you might want to look at, well, it just left me. Oh, is the values as they go up, what happens here. So let's go back to the calculator. And that's again why I said 6.1 and 6.2 was a lot of calculator work. So let's trace the first one. Let's find, all right, let's go to 1.96. That's close to 2. 2 and 4. Okay, if I put a 2 and a 4 right here, let's say this is 2 and 4. Then if I go 4 this way, 1, 2, 3, 4, this point right here is going to be 4 comma what? 2. Okay. If I go to 2, 4 on the black line, and I go to 4, 2, these 2 points are going to be across the oblique asymptote from each other. What is the oblique asymptote? Well, the oblique asymptote is going at a 45-degree angle. And that's what a lot of the inverses are looked at. So these two are mirror images of what? Each other. That's what an inverse gives you. Inverse gives you the mirror image about the oblique asymptote, which is that 45-degree angle. Capiche? Let's see what y'all put in the chat. Nothing. So what should you be able to do in 6.1? You should be able to find the inverse algebraically. You should be able to graph it on your calculator. And you should be able to find points along and make sure you understand that across the oblique asymptote is the mirror image point, which will be the opposites. So 2, 4 would be 4, 2. 1, 6 would be 6, 1. Negative 1, 2 would be 2, negative 1. Now let's see what I've covered, and you'll see when I go to the slides, you're going to say, good gosh, all them slides said all that? Yep. Okay, there's the inverse, one-to-one function. What is a one-to-one function? I'll show you that right quick. One-to-one function means do the vertical line, do the horizontal line test. Let's write that down. I'm just going to write all three things down right quick. 1, be able to algebraically find. 2, be able to graph it. And when I say graph it, I mean on the calculator, and be able to manipulate it, be able to find things on it. 3, make sure you know that x comma y is going to go to y comma x around the oblique asymptote. And then make sure you can find a one-to-one using the horizontal line test. And this red one is going to the trash can. So what does that mean, Hubert? Well, when you're given a graph, the horizontal line test, and I'm going to draw a graph down here. And here's the function. You draw a horizontal line. And it crosses twice. So this is not one-to-one. If it crosses once, it is one-to-one. So if I give you another graph, and let's say this is a hyperbola that looks like this. And you draw a horizontal line through it. And it only crosses what? Once. That is a one-to-one. Now, what does that mean? Well, it basically means for every x here, you've got 2 y's. I mean, for a y function, you got 2 x's. This is the opposite. For every x function, you have 2 y's, pretty much. Okay, so what does that mean? Well, at x is equal to 1, I've got a dot there, and I've got a dot there. For -1, I've got a dot here, and I've got a dot here. So for each x, I have 2 y's. For each y, I have 2 x's. That's the difference between the two. Each x, I have 2 y's. And for each y, I have 2 x's. Well, I think I got it backwards. For each x, that's right. For each y, I have 2 x's. And for each x, I have 2 y's. Sorry about that. So here I have y is equal to 2. Let's say y is equal to 2. y is equal to 2, I have an x here, and I have a positive x here. Here's my plot right here, but that means right here, for each x, I have 2 y's. And that's a 1-to-1. So that's the fourth type of question I could ask you on the test. Draw a horizontal line through a graph and tell me if it's a 1-to-1 or not 1-to-1. So it's not a real big deal. I'm trying to find my PowerPoint. Just give me a minute. There's the question right there. So let's look at this one. And the best way to find it is to graph it. So the square root f of x is equal to the square root of 25 minus x squared. So I'm going to take my handy dandy calculator. And I'm going to graph clear, clear. And I'm going to say the square root, or parentheses, 25 minus x squared, close parentheses, raise that to the 0.5 power, and graph. And that's what it looks like. And that should have a radius of 5. I'm going to blow it up a little bit. Zoom in. And that's too much. Zoom fit. Zoom standard. There, that's good enough. Now, if you draw a line through that, I mean a horizontal line through that, you would what? Hit it twice. So not a 1-to-1. Not a 1-to-1. Let's look at the second example. Negative 4x plus 12. I can tell you that's one right off the bat, but we'll go ahead and do it. Let me get back to negative 4x plus 12. F of x is equal to negative, I'll do it in another color, negative 4x plus 12. Well, we got a y-intercept of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative slope. And it's 4 down or 4 up. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Draw a vertical line through it. It's 1 time. This is a 1-to-1. And that's how you do a one-to-one function with the horizontal line test. And let's see what they say. I say no and yes. Not a one-to-one. Is a one-to-one. Now, what are they doing algebraically? They're setting it equal to itself. Okay? So on that first one, on the second one. The first one, they choose A is equal to 3 and B is equal to negative 3. Why? Because of what I just showed you right here. Negative, positive. That's why. And if you get a plausible answer for negative x and positive x, let's go back to the, oh Lord, this is aggravating. There's the negative x, and there's the positive x. And you plug those in and you get a plausible answer, then that means it is not a one-to-one, because that means that it hits twice. Okay? Here, they set f of a equal to f of b. In other words, they set this one up to this one and see if you get a plausible answer. A is equal to b. Yes. If you got a is equal to a, then it wouldn't be a one-to-one function. And there's the horizontal line test. Okay, I'm going to let you write those two examples down. That's the not one-to-one. And you can put that with my examples. And that is one-to-one. So there's two more examples of not one-to-one and what is one-to-one. Again, we're not going over a lot of real rocket science algebra. We'll get to the rocket science when we get to the log, so I'm going to keep on going. Okay, this one you could actually, this is the test question I would give you on a test. Okay, are these inverses of each other? Well, first thing I would do is write this one down and algebraically figure the inverse and see if it looks like that. So this is a test question. So let's do this one. And I will go to my handy dandy. I have to keep switching back and forth, back and forth. X cubed minus 1. F of x is equal to x cubed minus 1. Number 1, write as y. Y is equal to x cubed minus 1. Switch x and y. Solve for y. So y inverse is equal to the cube root of x plus 1. And that is a test question. Now, of course, you can graph. You would graph this one as f of x, and you would graph this one, and another way of writing this would be f of negative 1 of x is equal to cube root of x plus 1. That's another way of writing the inverse function. So let's go back to the question. And that's what they got, the cube root of x plus 1. So if you graph those two, so let's go to the graph. Clear. And I'll do the first one in black. X cubed minus 1. And the second one will be in magenta. That's going to be cube root. So I'm going to raise it to the 1/3 power. So that's going to be x plus 1, x plus 1, close parentheses, raised to the 1/3 power. And graph. And there you go. If you want to check it to see if it's, just put in y is equal to, and go down here to the green and type in y is equal to x and change it to a dashed line. Well, it was supposed to dash it, but it didn't. But you see that these points are mirror images of each other. Hopefully you should feel good about yourself. That one you would graph, you would just graph that in a calculator, and I'm not gonna worry about that. Okay, so that's 6.1. Let's look at 6.2. Well, if I can find everything I need to find, I'm about ready to quit. Go get me a job with Burisma. And some of y'all have no idea what I'm talking about. That's sad, but anyway, get me $183,000 a month. We talked a little bit about exponential functions. I told you a good one is, there it is, f of x is equal to 2 to the x power. We talked a little bit about this, and I told you this was going to be your decay and half-life and what's it called, carbon dating type questions. So you need to be aware of the x power and what does it look like. And I gave you this as a parent graph, and I told you that it will always cross at 1, and you'll either have a negative, which means decreasing, or you'll have a positive, which is increasing. Now, we touched on that a little bit last week. And that's what it looks like in the table. That right there is what it looks like on the graph. So that's a test question. Make sure you can graph 2 to the x, and what if I put a +1 and that type of thing, horizontal shift and things like that. Let's see what else they got here. That's 1/2 to the x. Make sure you can graph that on the calculator. It's always going through 0 and 1. And you can find any point, either use trace or use the window. I'm not going to go through that with you. Okay, that's the same thing. What happens with a -2? It goes the opposite direction. We talked about that with parent graphs. That's not a big deal. What if you have a -x? Well, a -x says I'm going down like this. Okay, so that's the difference. You can see that on a calculator. So I'm not going to worry too much about that. There's your horizontal shift, 3 to the left. Okay, we already talked about that. We talked about that last week with the vertical and horizontal shift. We talked about all that. Vertical shift. The 3 is not attached to the x. The 3 is attached to the 2 to the x. If it's attached to the 2 to the x, then it's a vertical shift. Okay. This you would punch in a calculator, or you could do it by hand, but I don't think you'd want to do that. But you would just raise 2 to the square root of 6 power. That's not a big deal. Same thing here. Write this one down. This is a test question, and it's also a test question on a standardized test. This one's very important. And I've got to shut down after this one probably. Yes, class is over at 10, and some of y'all are going to convulse. So 25 to the x power is equal to 125. When you're looking at one of these problems, you're looking for compatibility. I don't know how to spell compatible. Is it A-B-L-E? Compatible? Y'all help me out. Some of you spelling gurus out there. Is compatible spelled with an A-B-L-E? Is it I? Okay. It was I thought it was A. Oh well. Shows what I know. Okay. So what do you mean compatible? Well, you see the 5 and the 5, then I know that these two are multiples of 5. That's compatibility. What if this was a 2 and this was a 25? There'd be no compatible. It would be no compatible, no speak English, no compatible. Okay? So you got to look for some kind of compatibility. I can rewrite this as 25 to the x power is equal to, what is this? Well, the compatibility is this is 25 to the what? Or let's see, I could rewrite this as 5 to the second power raised to the x power is equal to 5 to the third power. And remember, if you have an equation, and I gave you this in your properties with the exponents and logarithms, we'll get to them later. If you have the same base and they're equal to each other, what can you do to the exponents? Set the exponents equal to each other. Excuse me. That x could be multiplied using the power rule. That's 5 to the 2x is equal to 5 to the 3. My bases are the same. Therefore, 2x is equal to what? Y'all settle down, please. 2x is equal to 3. Divide by 2. X is equal to 3/2. So 25 to the 3/2 power is equal to 125. So what do? You look for compatibility. 2. You expand the relationship. What does that mean, Hubert? Well, once you find the compatibility between the two numbers, and we found out it was 5, then you expand that relationship. 5 to the what is equal to 5 to the what? And then 3, you're going to see same basis equal exponents. And of course, you'll hit solve after that. Okay, we'll stop there. And that is at 6.2. So if you're working on homework, you should be able to start 6.2 homework. You should be able to start it. I don't know how far you'll go, but you might be able to start it. 6.1 and 6.2. Let me go to the attendance now. Shut the share content, should be off. Stop recording.